Hey guys, sorry I'm not there today. I got my COVID booster shot and I just don't feel very good, but I'm gonna go over the notes that we would have gone over in this video and hopefully that'll be okay. And then I can answer any questions we have about them tomorrow. But what we're gonna do today is we're gonna find the derivative of tangent, cotangent, cosecant, and secant. And the reason we didn't do this when we found the derivative of sine and cosine is because for a lot of these, you need the quotient rule to find these derivatives. Last time we did something like this when we found the derivatives of sine and cosine, I showed you how we find them. And then once you figure out how to find them, you can just memorize them. But what we're going to go over right now is really important if you ever forget what the, if you ever forget to memorize the derivatives, you can always figure it out using these methods. So there's some helpful information you need. So the first part of the information is about derivatives, and then the second part is identities. At this point, you're really going to have to start memorizing these identities. I think on Monday, we have a really short class, so I might bring some flashcards in, and maybe we can all make some flashcards, but you really got to start memorizing these if you haven't already. But first, let's go over the derivative of sine and cosine. So the derivative of sine, just a reminder, is cosine of x. And then the derivative of cosine of x is negative sine of x. Also, this is not related, but I just want to make sure I say this just in case I forget. Tomorrow during the advisory is the day that there should be a Zoom meeting with some old calculus students or students that are doing engineering in college. So I would love if you guys could go to it. It's during 6B. So if you want, I don't know what I'm saying, but just try your best to go if you can. I'll send a Zoom link out and I'll remind your advisory teachers. So sorry, side note. The other thing you need to do these is these trig identities. So just a reminder, these are all the quotient identities, or at least the top four are. Tangent of x is sine of x over cosine of x. Cotangent of x is just the opposite. So cotangent of x is cosecant or cosine of x over sine x. And then cosecant of x is 1 over sine of x. And then secant of x is 1 over cosine of x. So you'll need that. And then finally, this last one is a Pythagorean identity. Just a reminder that cosine squared of x plus sine squared of x equals 1. So that's the last one. And if you need any more time writing that down, feel free to pause, but I'm going to move on. So we're going to start by finding the derivative of tangent of x. So we're trying to find that derivative, but we don't know what the derivative of tangent of x is. So what we have to do is we're going to rewrite it. So from the last side, we know that tangent of x is the same thing as sine of x over cosine of x. So instead of finding the derivative of tangent of x, we're just going to do sine of x over cosine of x. So we're going to do the derivative of sine of x over cosine of x because that is equal to the derivative of tangent of x because those are the same thing. So I'm going to write so these are all the same thing. So in this blurb, sine of x over cosine of x, there is a quotient going on. It's a rational function. I guess it's more than a rational function because it has trig in it. But big idea, there's an x on the top and an x on the bottom, which normally indicates to me maybe I can use the quotient rule. So I can use the quotient rule. So that's what I'm going to do. I'm going to find the derivative of the top, and the derivative of sine of x is cosine of x. And then I'm going to multiply that by the original denominator, which is again cosine of x. Quotient rule is always subtraction, so I'm going to put a subtraction sign there. And then my original numerator goes on top, and then the derivative of my denominator goes on the bottom, and that is negative sine of x. And then down here below, I'll just do cosine squared, like that. We have cosine x times cosine x on the top, so that's the same as cosine squared x, and sometimes this is how we write it. This is a more popular way to write it. You just put that 2 between cosine and x, and that's the same thing as writing it this way. Those are the exact same thing, just different ways to write them. Oops. And then you'll subtract. This ends up being a negative sine squared of x because it's sine of x times negative sine of x, and that's negative sine squared of x all over, and I'm going to rewrite this as cosine squared x. This ends up being cosine squared x plus sine squared x. And a second ago, I showed you that cosine of squared x plus sine squared x equals 1 because of that derivative rule, or because of that Pythagorean identity. And then up here, I'm going to write, so 1 over cosine of x equals wait, hold on. Did I write it down? Sorry. 1 over cosine of x equals secant x. So that means that 1 over cosine squared of x just would equal secant squared of x. So at the end of the day, our derivative is secant squared of x. So the derivative of tangent of x is secant squared x. And that's the process that people have used to figure that out. But now you can just memorize that the derivative of tangent of x equals secant squared of x. So you can just kind of memorize that now. But if you ever forget, this is how you would do it. We're not going to go through the process with all four, so not with tangent of x, cotangent of x, cosecant, and secant squared of x, or secant of x, but we are going to go through it with, instead of doing secant x, I'm going to do cosecant x here. So we're going to do the same process with cosecant of x. So we will take the derivative of cosecant of x, and cosecant of x is the same as 1 over sine. So those are just my quotient rules, so these are equivalent to each other. And I know what the derivative of sine is, even though I don't know the derivative of cosecant of x. So for this one, quotient rule is really important to use when there's an x on top and an x on bottom. We actually only have an x on the bottom, but the way that we would do this without using the quotient rule, you guys haven't learned yet. We will do that in Unit 3, and it's called the chain rule. So because you don't know how to use it yet, we can use the quotient rule. We can always use the quotient rule. Sometimes it's just more work, but today it will be fine. So we're going to use the quotient rule to find the derivative of 1 over sine of x. So the derivative of the numerator is 0, because the derivative of 1 is 0. And I'll multiply that by sine of x. And then I will subtract just the original numerator. And I will multiply that by the derivative of the denominator. So the derivative of sine x is cosine of x. And then I will square my bottom, and I'm going to write it like this. This is the same thing. So I'm just squaring that, just a different way to write it. I'm going to clean up my numerator. So 0 times sine of x would be 0, so that goes away. And then this would be minus cosine of x all over sine squared of x. And I'll rewrite it like this. This is correct. There's just a more simplified version of it. And when we actually do trig, it's important to simplify these basic ones. So we're going to rewrite this as negative cosine of x over sine of x times 1 over sine of x. So I'm actually going to separate my denominator. So instead of it being sine squared x, I'm just going to do sine times sine because these are the same thing. And then negative cosine of x over sine of x. Well, cosine of x over sine of x is equivalent to cotangent of x. So it's negative, so it'd be negative cotangent of x. And that's just because, just some side info over more, cosine of x over sine of x would be negative cotangent of x. So that's why I'm replacing that. And then 1 over sine of x is the same as cosecant of x. And that was from that very first page because 1 over sine of x is equal to cosecant of x. So that's how I'm replacing them. And then my final answer is just negative cotangent of x times cosecant of x. And that is what the derivative of cosecant x is. So pause that. Maybe if you have any questions, talk to your classmates about it real quick. You can send me an email. That is how you find the derivative of cosecant. The process with cotangent of x and secant of x would be really, really similar to that, but we're not going to go over it for the sake of time. And I'm just going to tell you what all the derivatives are now. So here are our trig derivatives. We're going to start from the top just so we can continue to practice. The derivative of cosine of x is negative sine x. And this is what we'll make flash drives for, or we can make flashcards for this too. The derivative of sine of x equals cosine of x. So those are the ones that we did last week. the derivative of the tangent of x equals secant squared of x, and that's what we figured out earlier today, or like in the example a few ago. The derivative of cotangent of x is negative cosecant of x, cosecant squared of x, sorry. The derivative of cosecant x, which was the last one we just did, is negative cosecant x times cotangent x, and I think we just wrote it in the other order, but it doesn't really matter which order you write it in. You can write cotangent first or cosecant first. And then finally, the derivative of secant x is secant of x times tangent of x. So those are all your derivatives. Take a second and write those down, and we just have to memorize those at this point. But if you ever forget, you can do the method that we just used. Okay, so using that information, we're going to do 2 practice problems. So the first one is find the derivative of, okay, of f of x equals 3 cotangent of x plus natural log of x times cosecant of x. So we're going to find the derivative of this. So we can first start by taking the derivative of 3 cotangent of x. So 3 is just a coefficient, so I'm going to write that down. And then the derivative of cotangent of x is negative cosecant squared x. And that's just from what I memorized. This next part's a little bit more challenging because there are 2 functions multiplied together. So just continue to practice recognizing that. I think it's easy to use the power rule or the product rule when you're doing product rule notes, but it's a little harder to recognize when you're not. For example, when we did the FRQ yesterday, not everybody recognized that bottom problem as we need to use the product rule. But because these are 2 functions multiplied together, we need to use the product rule. So I'll kind of section this out a little bit, but we don't really need all of these brackets. But you'll first start by taking the derivative of the first function, which is the natural log of x, and the derivative of that is 1 divided by x. And then we'll keep cosecant of x there. And then we add because it's the product rule. So we subtract for quotient, we add for product. And then I'll rewrite the natural log of x, and then I'll write the derivative of cosecant of x, which is negative cosecant of x, cotangent of x. And I don't really need these big brackets around here. I just wanted to indicate this whole section is just the derivative of this part right here. So if I clean this up a little bit, I'll get negative 3 cosecant squared of x plus, I'm going to get rid of these brackets. 1 over x times cosecant of x is the same as cosecant of x over x. So I'm just going to rewrite it like that. And then I can just so it's natural log of x times cosecant of x times cotangent of x. So I'm moving that subtraction sign out front, and then these are all just getting multiplied by each other. And that is our answer. So that is the derivative of 3 cotangent x plus the natural log of x times cosecant of x. Okay, pause it if you need more time. Again, send me an email or ask a classmate for help. We're going to do one more example. So this got cut up a little bit, but it's example 4. Find the equation of the line tangent to f of x equals the tangent of x at pi over 4. So we're trying to find the equation of the line tangent to f of x equals tangent of x at pi over 4. So the equation of the line tangent, there's 2 things we need. First, we need to find the slope of that tangent line. So there's 2 things we need. The first thing we need is the slope of the tangent line. And we also need a point on the tangent line. And just a reminder that a tangent is just a number that intersects the graph at exactly 1 point. So in this case, it would intersect tangent of x at pi over 4. So to find the slope of the tangent line, that's just the derivative. So slope of the tangent line is the derivative at that specific point it was given. So this will be the derivative at pi over 4. So I'll use f prime of x here. And what I mean by that is I'm going to use the derivative of tangent. And then the point on the tangent, we find that from the original function. So we find from just f of x. So let's first find the derivative of the tangent line. So we're going to try to find the slope first. So the derivative of f of x is going to be f prime of x equals, so it's just the derivative of tangent of x, and the derivative of tangent x is secant squared x. So we found the derivative of tangent of x, but now we specifically need to know what is the derivative at pi over 4. So I'm going to do f prime of pi over 4, and this is also where we just got to know our unit circle. So just continue. I know you don't have much free time, but if you ever find any free time, just continue to look over that unit circle. I can rewrite secant squared of x as 1 over cosine squared of x. Or sorry, yeah. No, I got it. Cosine squared of x of pi over 4. So they're just reciprocals of each other, and I can rewrite that. And there's no secant on the unit circle, so I'm going to use cosine squared instead. And I know that cosine of pi over 4 is the square root of 2. And I'm doing that twice because it's cosine squared. So I'm going to do the square root of 2 times the square root of 2 on my denominator. That ends up being 1 over the square root of 4 over 4, which equals 1 over 2 over 4. And that would equal, I'm going to rewrite this as 1 over 1 divided by 2/4, which would equal 1 over 1 times 4 over 2, which equals 2. So f prime of pi over 4 is 2. If you got lost on the fractions, just do your best. We're just basically dividing a number by a fraction. That's what happens. But big idea is the slope of the tangent line is 2. Now we just need to find another point on that line, and we use the original function to do that. So I'm just going to plug in pi over 4 for tangent of x. So I'm plugging in pi over 4 for x. This gives me, I'm rewriting tangent as sine pi over 4 over cosine of pi over 4 because tangent's not necessarily on the unit circle. Sine pi over 4 is the square root of 2 over 2. I'm just getting that info from the unit circle. And cosine pi over 4 is the square root of 2 over 2. And those are the same thing, dividing by itself, so that equals 1. And so a point on our line would be pi over 4, 1, because pi over 4 is our x value and 1 was our y value. Now I need to put all of that into my tangent equation, and I'm going to use I'm just using y minus y1 equals m times x minus x1. So I'm using my point slope formula. I'm going to do y minus 1 equals, my slope is 2 over x minus pi over 4. And that is our answer here. And problems like this aren't really going to go away, so if you need help with it, again, let me know. Find the equation of the line tangent to a certain point. It's just a really popular question, you'll see. So yeah, if you have any other questions, let me know. You do have some homework today. It's on Google Classroom, so you can check that. It's out of your textbook. And if you need any help, like I said, just send me an email, and then make sure to go to that calculus, I don't know what to call it, calculus Zoom session tomorrow to ask some questions. So thank you guys, and I will see you tomorrow, hopefully.